So we're in section 7.2. In section 7.1, we estimated a population proportion. We're going to be estimating a population mean. And the best point estimate here is going to be our sample mean, our X bar. These are our key concepts. And so two things are going to be happening. We're going to estimate when we don't know sigma and when we do know sigma. And we're going to be introducing the t-distribution. So again, this is estimating a population mu when sigma is not known. So if we want to construct an interval, we need to use an estimate for the population mean. We need to know that the sample is simple random, and either or both of these must be satisfied. The population is normally distributed, or the number of trials, or n, is greater than 30. So we're going to be using t-distributions when sigma is not known. So I'm going to repeat that again, and I'll repeat it again at the end. T-distributions when sigma is not known. And we'll be using a TI-84 rather than the table. So instead of a critical value z-score, we're looking at a critical value t-score. And so what we'll need to determine these t-values, we'll need the degree of freedom, which is n minus 1, and the probability. And we'll find the probability using the confidence interval in a graph, right, our sketch, and determining the area to the left of the t-value. It's kind of similar to z-values, right? So our confidence intervals are going to be really similar. If we've got a 0.95 confidence level, then our alpha is 0.05. So these are the calculator steps for the TI-84 to find the critical value t sub alpha over 2. So we'll do second vars. We'll go to inv t, and you might have what it looks like here on the screen, or you might just have to type it in probability to the left, comma, degrees of freedom, depending on your screen. So let's do an example. So it wants us to find the critical value t sub alpha over 2 corresponding to a 95% confidence level, given that the sample size is n equals 15. All right, so I need to kind of find the area to the left, right? So we know here that these areas are alpha over 2. So if we've got a 95% confidence level, then our alpha is 0.05. Then alpha over 2 is 0.025. So this is 0.025. And when we type it into the calculator, we want the area to the left, and all of this is 1 minus 0.025. All right, so we also know n is 15, and our degrees of freedom is n minus 1. So our degrees of freedom here is 14. So this is the information we need. Let's type it into our calculator. So we're going to type it in. We're going to go to stat. Turn it on. Stat. We're going to go to tests. Ooh, excuse me. We're going to go to second vars. Sorry, got ahead of myself. Second vars because we want distributions. We're going to go down to inv t, INVT. And so they actually ask us here, you know, the area. Yours might look different, but I'm just going to type it in 1 minus 0.025. And my degrees of freedom is actually 14. I'm going to hit paste, hit enter, and my critical value is 2.14. 2.1, yeah, so t's alpha over 2, 2.145. Give me 3 values if you like. So go ahead and give this one a try. In this particular case, I give you the data that they're talking about from a previous example here, but the only thing you really need here is that the n is 50. And there's the solution. So just some points about the t-distribution. It looks similar to a normal distribution. It's got that same general shape, but it's not exactly the same. It does have a mean of t equals 0, so a standard distribution has z equals 0, but the standard deviation is not 1, right? In the standard normal distribution, it is 1, but in the t-distribution, it is not 1. But as the sample size gets larger and larger and larger, it gets closer to the standard normal distribution. So how we'll actually be constructing a confidence interval is we'll be using our calculator rather than these steps here. So first we want to before we even type it in, we want to verify that the sample is simple random and that it's either normally distributed or n is greater than 30. Once we have that, we're going to use this. Now I just want to make a note here. we're still talking about sigma is not known. So this will be later. We'll use this later. All right, let's take a look. Now, there's two things that can happen. You can either use data or stats, and we'll look at both of those in the calculator. If you type it in, you can use the data and put everything in L1. If you have the stats, you would just type that in as well. So example 2, we've got all this data here, and it wants us to use the sample data to construct a 95% confidence interval for the mean birth weight of the girl. So first, we can assume it's simple random based on who we got the data from, and it is normally distributed as well. We can assume that it's normally distributed from a previous problem. This one actually states that it's normally distributed. So let's go to our calculator. And we're going to actually have to type all this data in because they don't give it to us. So I'm going to go into Stat, Edit, and I'm going to clear this all out. And I'm going to type it in. And when I'm going to pause it and press play, you won't know the difference, but it's going to pre-populate here. Okay, and like magic, they're all populated. All right, so then I'm going to go into Stat, Tests, and now I want the t-interval test. There we go. I'm going to hit enter. Now, here's the stats. If I knew my x bar and my sample standard deviation and my n, I would calculate it there, but I actually don't, so I'm going to go over to data. My data was listed in L1, and my confidence interval is 0.95. Now, another way is you could run one variable statistics and get that data, but it's an extra step. So here we go. And there is my interval. So how we would actually write that interval would be 29.3 is less than mu, we're talking about the mean, which is less than 32.5. So that would be 29.3 is less than mu, our population mean, 32.5. And we might actually even just put in like the hectograms if we wanted. And so use the sample data to construct a confidence interval. That's the confidence interval. So how would we interpret it? It's very similar to what we did in section 7.1. We are 95% confident that the interval from 29.2 to 32.5 actually does contain the true value of mu. So go ahead and give this one a try. And I went ahead and I did the one variable statistics. You could have done the exact same thing as me, but there is your, it's in red here, but that's what I got from the calculator. So we can find the margin of error using this formula here, or we can, if we already know the confidence interval, we can actually use these formulas as well.